Hello friends, this is Road to IIT and today we are going to move forward on thermodynamics. So before starting today's lecture, I'm going to tell you one important thing that please make a note of this all the stuff because notes are going to be helpful you when the exam time is there. The notes are important when you want revision, so please make a good note of a formula, a good notes of a solved problems of each and type of category. Okay, so please make notes. So let's get started. Today we are going to see some various processes in the thermodynamics. So first of all, starting with isochoric process. That process is also known as a constant volume process. In constant volume process, the equation of state for ideal gas, as we know, PV is equals to mu RT, the ideal gas equation. And if you take volume as a constant, then P is proportional to T. That means P1 upon T1 is equals to P2 upon T2. This is the equation of gas, ideal gas, okay, for a constant volume process. Now see, if you draw the PV diagram here, then PV diagram is a perpendicular line from the x-axis, line perpendicular to the x-axis. That means volume is constant here. Volume V is equals to constant. And as we know the formula of work done, P into delta V, P into V2 minus V1, but volume is constant. That means work done is 0. Now if work done is 0, then delta U is equals to Q minus W, the first law of thermodynamics. According to that, W is 0. That means delta U is equals to Q. Okay, a very simple thing, a very easy thing to be remember. Then the next process, it's isobaric process. Isobaric process, that means pressure as a constant. Now again, PV is equals to mu RT. If pressure is constant, that means volume is proportional to temperature. That means V1 upon T1 is equals to V2 upon T2. A very simple thing. This is the equation of gas for constant pressure process. Now work done, the basic formula of work done, integration of V1 to V2 PdV. See, this formula is the very basic formula of work done. You can apply this formula for any damn process and that gives the correct answer. Now here P is a constant, so integration dV, it's V from V1 to V2, so P V2 minus V1 as the work done. So W is equals to P delta V for isobaric, that means constant pressure process. Okay, then it's isothermal, one of the most ideal gas equation. PV is equals to mu RT. Here T is a constant, mu is a constant, I is also a constant. That means mu RT both as a constant. That means PV is equals to constant. Now that means the equation of this isothermal process is P into V is equals to constant. Now as we know, PV is equals to constant. That means P1 V1 is equals to P2 V2. P1 upon P2 is equals to V2 upon V1. Okay, now temperature is constant. That means the temperature difference is 0. And we know the formula of internal energy. The formula of internal energy, it's mCV delta T. mCV T2 minus T1. T2 minus T1 is 0. That means delta U, change in internal energy, is 0. Okay. According to the first law, again, delta U is equals to Q minus W. Delta U is equals to 0. That means Q is equals to W. Okay. Now, what is W here? What is the formula of W here? Okay. Here, the formula of W we have is nRT ln V2 by V1 is equals to nRT ln P1 by P2. Then, how this formula is derived? The most important thing. Here, you can see ln V2 by V1. That means you can say like this, ln final volume upon initial volume, or ln initial pressure upon final pressure. Okay, please remember like this, that is final volume upon initial volume and initial pressure upon final pressure. Okay, now let's derive this formula first of all. Okay, we have proof here. We have PV is equals to nRT. Okay, you can say like mu RT, whatever you take. PV is equals to nRT. So here P becomes nRT by V. Okay, we have the basic formula of work. basic formula of work done, that is integration of P dV. Now again, integration of P dV, put nRT by V here, that's nRT by V, nRT, all are the constant, integration V dV, integration of V dV, that means Ln, nRT as a constant, integration of 1 by V dV, that is Ln V. Limits are here V1 to V2. Now upper limit minus lower limit, that means Ln V2 minus Ln V1. Now in the, as we know, the subtraction can be written as division, so nRT Ln V2 by V1. Now here Ln, that means log with the base e. Now if you have the log with the base 10, then you have to multiply it by 2.303. So here you can also say that 2.303 nRT is missing here, 2.303 nRT log V2 by V1. Okay, here log is with the base 10. Okay, now again here you can see V2 by V1, but as we know that in the thermodynamic isothermal process, V2 by V1 can be written as P1 by P2. So here you can replace it, V2 by V1 can be replaced as P1 by P2. So the formula of work done can be given by two basic formulas, nRT ln V2 by V1 is equals to nRT ln P1 by P2. In thermodynamics and physics, the formula has to be remembered. Without formula, you cannot do anything. The formula and concept are most important thing to solve the problems. Exams, theoretical questions are also there. Like this type of questions are also there. That in which process the change in internal energy is 0. So as we know that in the isothermal process, this is possible. Change in internal energy is 0. Again, in which process work done is 0. This type of questions are there in the competitive exam. So please remember the concept. Okay. Let's move forward to the next process. That is the most important process, that is adiabatic process. In adiabatic process, no heat transfer is done. That means Q is equals to 0. No heat transfer is done. That means Q is equals to 0. Now again, first law of thermodynamics, that means delta U is equals to Q minus W. Q is 0, that means delta U is equals to minus W. Now, what is the formula of W here? The formula of W can be written as P1 V1 minus P2 V2 upon gamma minus 1. And P1 V1 as ideal gas equation can be written as nR T1 minus T1, and this can be written as nR T2. So finally, it can be written as nR T1 minus T2 gamma minus 1. This is also formula of work done for the adiabatic process. We are not going for the derivation here because we don't need it. Okay, don't do that thing that you don't need. Okay, so here the formula is important. Now what is gamma here? Gamma is new quantity here. Gamma is known as adiabatic index. Okay, gamma is known as adiabatic index. The value of gamma is, see here, value of gamma is Cp by Cv. Cp by Cv. Almost for most of the cases you can say gamma is 1.4. For most of the cases gamma is 1.4, and you can also remember this equation Cp minus Cv is equals to R for the finding the value of Cp and Cv, which can be helpful to find the value of gamma. RV, as we know that it's 8.314 joule per mole Kelvin, universal gas constant. Okay, now the equation for adiabatic process, the process equation for adiabatic process, as we see in the isothermal, PV is equals to constant. In adiabatic, the process equation is PV raised to gamma is equals to constant. PV raised to gamma is equals to constant. That means P1 V1 raised to gamma is equals to P2 into V2 raised to gamma. Okay, now this is here in the form of P and V. Now we have three main properties here. First of all, it's P, then we have V here, then T, that is temperature. So we can have three formulas here. First of all, in PV, in the terms of PV, we have PV raised to gamma is equals to constant. Now in the term of P and T, in the term of P and T, so just put PV is equals to nRT by PV is equals to nRT. Just put V is equals to nRT by P, nRT by P, and we have this equation, T raised to gamma upon P raised to gamma minus 1 is equals to constant. Okay, T raised to gamma upon P raised to gamma minus 1 is equals to constant. Again, you can have this equation in the form of V and T, and for that we have here PV is equals to nRT, so P is equals to nRT by V. Okay, again PV raised to gamma is equals to constant. As a P we have nRT by V here, nRT V goes here, so V raised to gamma minus 1, so that means T into V raised to gamma minus 1 is equals to constant. Okay, so this is in the form of T and V, and this is in the form of T and P. You can prove that easily by using a simple equation. You just have to remember one equation, that is PV raised to gamma is equals to constant, and by that using this method you can prove this also. Okay, please remember all the formulas, all 15 to 20 formulas for all the processes. These are very important to be remembered. Okay, so this is all about today's video. Keep watching for more update on physics and maths. Thank you for watching this video, and if you like this video, don't forget to share it and hit that subscribe button. Thank you.